Hi everyone, welcome back to our channel. Today we are going to discuss about different Laplace transformation formulas. This is very simple. So let's try to write down each function step by step. The given function is f of t and we need to find out f of s for the given function, and we are going to find the Laplace of this function. Okay, so let us try to see one by one. So the given function is f of t. So Laplace of 1 is nothing but Laplace of constant. F of s is 1 by s. Okay. So the given function f of t is k. Therefore, Laplace of k is equal to, you are going to get the answer as constant by s. So constant by s is 1 by s. Constant k is k by s. So Laplace constant of an scalar k into f of t is nothing but Laplace of k into f of t is nothing but it follows the scalar for theorem. So k is a constant. Laplace of f of t is f of s. Next one, Laplace of t to the power n. Okay, so Laplace of the given function f of t is t to the power n. Laplace of t to the power n is n factorial divided by s to the power n plus 1. Okay, so similarly the given function is t to the power 1. So Laplace of t to the power 1 is equal to 1 divided by s to the power 1 plus 1. I can write down as 1 divided by s square. Therefore, Laplace of t is 1 by s square, where this t is also called as a unit ramp function. Okay, so the Laplace of unit ramp is 1 by s square. Okay, so the next one is e to the power minus at is the given function f of t. So Laplace of e to the power minus at, we can write down it as 1 divided by s plus a. Next one is e to the power plus at. It's nothing but Laplace of e to the power at is equal to 1 divided by s minus a. Next function is Laplace of e to the power minus at into t to the power n. So already we know Laplace of t to the power n is n factorial divided by s to the power n plus 1. But here we are having e to the power minus a. Laplace of, we have negative and that too in exponential, automatically this will be an opposite sign, then you are going to get s plus a whole to the power n plus 1. Okay, so Laplace of t to the power n is n divided by s to the power n plus 1. But here we are having e to the power minus at, we can write down it as a, so this is minus, automatically you are going to get the opposite sign here, which is nothing but n factorial divided by s plus a to the power n plus 1. So Laplace of sine of omega t. So Laplace of sine omega t is nothing but omega divided by s square plus omega square. So Laplace of cos omega t. So omega of cos omega t, we are going to get it as s divided by s square plus omega square. Okay. So next one, Laplace of e to the power minus at into sine omega t. So here you can see here omega is not changing, divided by s square plus omega square, but s is related here. E to the power minus at is nothing but how much? S plus a whole square. So similarly, Laplace of e to the power minus at into cos omega t, there is no change. We are going to get omega divided by s plus a whole square plus omega square. Okay, so just e to the power minus at will be added to s plus a. Okay, so similarly, Laplace of sine hyperbolic omega t. So this we can write down it as omega divided by s square minus omega square. Similarly, Laplace of cos h omega t, we can write down it as s divided by s square minus omega square. Okay. Similarly, Laplace of t e to the power minus at, we can write down it as this as Laplace of t to the power n is 1 by s square. So but s is related with plus a, which is nothing but s plus a whole square is the Laplace of this function. Okay, so similarly, Laplace of 1 minus e to the power minus at, we can write down as Laplace of 1 minus Laplace of e to the power minus at. Laplace of 1 we can write down it as 1 by s. Laplace of e to the power minus at we can write down it as s plus a. Okay, so this is how to write down the Laplace. Okay, I will review the things again. Laplace of constant is 1 by s. Laplace of k is k by s. Laplace of k into f of s is k into f of s. Laplace of t to the power n is n factorial divided by s to the power n plus 1. Laplace of substitute n equal to 1, 1 divided by s square. Laplace of e to the power minus at is 1 by s plus nothing but when you get exponential minus a, automatically you will get opposite symbol which is nothing but plus a. Laplace of e to the power plus at we can write down it as 1 by s minus a. So Laplace of e to the power minus 8 into t to the power n we can write down n divided by s plus a to the power n plus 1. Laplace of sin omega t is omega divided by s square plus omega square. Laplace of cos omega t, here we are going to get s which is nothing but s divided by s square plus omega square. Laplace of e to the power minus 80 sin omega t, we are going to get omega divided by s plus a whole square plus omega square. All this, just do the transformation, we can write down the transformations. These transformations are very very important to solve the problems of Laplace transformation in transients as well as. So that is all about the lecture. Laplace transformation formulas, converting a given f of t function by applying Laplace will get the answer. So this Laplace transform is used to transform a given time signal into frequency signal which are nothing but s is equal to j omega. Hope you are able to understand the content. If you feel the content is useful to you, please like the video and share with your friends. And if you have any doubt, let me know in the comment section. I can answer your doubts. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. Kindly support this sort of free channel for the development of students and faculty. Thank you for watching. We'll meet in the another video. Yours obediently, Ram.